Welcome to the Business Talk, a global podcast series that highlights distinguished faculty members and their impactful scholarly contributions. I'm Deepak, your host from India. We are honored to have Dr. Vasant Honavar joins us as our distinguished guest on today's episode. Before we begin, allow me to introduce our guest for today's episode. Dr. Vasant Honavar is a professor of informatics and intelligent systems at Penn State's College of Information Sciences and Technology, where he served as the director of the Center for Artificial Intelligence Foundations and Scientific Applications and director of the Artificial Intelligence Research Laboratory. Drawing on decade of work at the intersection of computer science, cognitive science, and data-intensive domains, his research spans artificial intelligence, machine learning, causal interference, and big data analytics, with impactful applications in bioinformatics, health informatics, materials informatics, and algorithmic fairness. Professor Vasant holds a PhD in computer science and cognitive science from the University of Wisconsin-Madison, and his academic journey has bridged theory, methodology, and real-world discovery. He continues to shape the frontiers of AI and data-driven science through large-scale collaborative projects, interdisciplinary centers, and training the next generation of researchers in intelligence systems and data sciences. In this episode, Professor Vasant Honavar tackles one of AI's most pressing paradoxes: how do we hold systems accountable when they perform brilliantly yet lack genuine comprehension? His work, Responsible and Accountable AI, Competence Without Comprehension, and the Performance Responsibility Trade-offs, offers crucial insights. Let's not keep you waiting. Please join me in welcoming Dr. Vasant Honavar to the podcast. Professor Honavar, we deeply appreciate your gracious acceptance of our invitation. It's an honor and privilege to host you today.
Thank you.
Professor, you describe modern AI as exhibiting competence without comprehension. Can you walk us through what the distinction means in practice and why it fundamentally challenges our traditional notion of accountability?
Right. So, the modern AI systems like large language models, ChatGPT and others, right? They display a very impressive level of competence. So, for example, you could ask these systems a question about almost any topic, and they will give you a very fluent answer. And many times the answer may be right. Occasionally it may be wrong. There may be hallucination, facts that are made up, and so on. But it's hard to tell the difference. For a layperson, it's really hard to tell the difference. If you're an expert on a topic and you're using these systems, then you can sort of verify what it provides and make good use of these systems. But in general, the the level of competence that is described, I mean, that is exhibited by these systems is very impressive. However, there is no comprehension. So, for example, a ChatGPT can write an essay about uh, love or any other sort of human feelings without really understanding or ever experiencing what that is. So it can describe an apple in great detail, but it has never tasted an apple. It has never held an apple in its hand. So it really has no experience of an apple, right? So this is the paradox. So the one of the surprising things is that this level of competence can be displayed by a system that is doing essentially statistically next word prediction, right? So the next word, ChatGPT is just a very sophisticated version of what people used to do with Markov models, essentially predict the next word based on the previous words in the sequence. And so that's really and so when you talk about accountability, um, what does accountability really mean? I mean, is accountability means that you can hold an individual or an entity responsible for its um, actions. So, in what sense can you hold ChatGPT responsible for its actions, right? So things like judgment are inherently human, and so I think so that's kind of our challenge. It's really hard to hold these systems accountable in any realistic sense. So really, the accountability responsibility falls on the people that are using these systems and the extent to which they understand the systems, they can interrogate the systems, and ultimately make decisions or judgments based on what the systems provide them.
Professor, when we say an AI system doesn't understand what it's doing and what exactly is missing, is it causal reasoning, contextual awareness, or something deeper? And does that gap actually matter if the system performs well?
Yeah, well, in some cases it doesn't matter if the goal is just performance on some particular task, and if it can be validated with sufficient, rigor. So, for example, a system that is designed, to predict or identify, diagnose diseases based on MRI images. Well, if its performance is at the level of a physician or better, maybe that's good enough. But ultimately, right, so the system is not, cannot be held accountable for its mistakes. Human doctor has to be, right? So that's really the crux of the matter, right? Because what is, I mean, you asked a more complicated question. I mean, what is missing? So I think this is, deeply philosophical question, right? I mean, what is intelligence? What is understanding? We don't have very good, definitions of these, right? So for the case of AI systems, the initial kind of criterion that was proposed by Alan Turing was you consider a system intelligent if in a conversational setting you cannot distinguish its response from that of a human. So that's the Turing test. That has been passed by large language models. One could arguably say that they have passed that, right? So then what? Well, people came up with more sophisticated versions of this Turing test. So, for example, describing what's going on in a visual scene. Show an image or a video and try to describe what's going on. Well, I mean, the image, to a reasonable extent, modern AI systems can describe what's in an image. Um, a video, it depends on the depth of questions. I mean, if you're asking questions about what the intent of a character might be, those might be a little difficult for AI systems to currently tackle. But eventually, given enough training data, etc., even those might be well within reach eventually, right? So, so basically, a lot of these tests that were designed to assess whether a system is intelligent or not um, essentially look at behavior, the output. Okay. And from at least our experience with large language models, we know that we can, the you can achieve is impressive level of competence without understanding, right? I mean, so large language model really doesn't need to understand what an apple is to be able to describe an apple. Okay. Large language model doesn't need to understand what love is to talk about love. It could write a novel about love, right? Or grief or whatever, human feelings. So I think we don't have a good answer for this, right? So, so I would say it's an open question. I mean, in a sense that, the thing that we feel that there is something deeper about understanding versus it's something that you can evaluate purely based on behavior. That's kind of a deeply philosophical question. Empirically, it's very hard to evaluate it, right? Because all we can observe is a system's behavior. I mean, how do I know you are intelligent, right? I mean, I don't have access to the internal sense. So essentially, our interaction is what allows us to decide. But at the same time, there is this nagging feeling that because we know what the large language model is doing, uh, the the kind of things that we talked about, that maybe there is a gap. And when it comes to things like accountability and responsibility, that becomes this lack of clarity about what that gap is and what that entails is one that raises all kinds of questions. So, for example, legal questions, right? So if you made a decision based on what a large language model provided to you, who is responsible? Is it the person making the decision? Is it obviously you can't fine a large language model, you can't put it in jail, right? So who is responsible? Is the company that trained it? Is it the provider of the data that was used in the training? So where does the responsibility lie? That's the challenge.
Professor, you have identified a performance responsibility trade-off at the heart of AI governance. In high-stakes domains like healthcare or criminal justice, how should policymakers navigate this tension? Do we sacrifice some accuracy for explainability or vice versa?
Well, I mean, I think it really depends on the application. There may be situations where if you have statistically rigorous validation, you may be happy with accuracy, right? And even when you say explainability, it's not entirely clear what that means. I mean, the most sort of everyday, the current approaches in AI, the way the explainability is obtained is by being able to identify, um, if you have a predictive model, you try to identify what the features are or what the variables are that were important for making that prediction. But uh, prediction is not the same as causation, right? So there is a gap between the ability to predict versus the ability to really understand what the underlying causal mechanisms are. And so knowing what variables are used to make the prediction doesn't really explain the prediction in a fundamental sense. So that's a fact. I mean, it may help you to understand to some degree, but it's not a complete explanation of what's going on. It could also be, I mean, that there's many reasons why those variables were identified. It could be that the data was biased. There could be lots of reasons why, or it's just a correlation. There is no causal relationship, right? And so even the so-called explainability requires more work because explanation, what constitutes an explanation or an acceptable level of explanation depends on context. It depends on who the explanation is for, what you're going to do with the explanation, and on and on and on. Right? So, with that said, yes, I mean, there could be a trade-off between explainability versus predictive accuracy. And when one is more important than the other, or what the exact nature of the trade-off is, I think it's a context-specific kind of determination.
Professor, traditional accountability frameworks assume that decision makers can justify their choices. When AI systems operate as a black boxes, optimizing purely for performance, who bears responsibility when things go wrong? The developer, the deployer, or the algorithm itself?
Yeah, well, I mean, I think you can't assign responsibility to an algorithm. You can't assign responsibility to a large language model. I mean, the responsibility ultimately, judgment and responsibility ultimately have to rest with people, right? Now, that may be broken down based on, the details of a particular situation. So if someone sold you an AI system with the assurance that it performs at a certain level and it did not, then maybe the company that sold the system is responsible. Maybe the company used data from a third party and the third party guaranteed that the data was a representative data set, then maybe the data source, the provider of the data source is responsible. If there is an error in the algorithm, maybe the person that designed the algorithm may be responsible, right? But ultimately, from the standpoint of, and so this is a legal setup. I'm not a legal expert. One has to work this out, right? Ultimately, I think the responsibility has to rest with individuals or corporations that are involved that have a kind of a legal, from a legal standpoint, or a moral standpoint, or ethical standpoint, have responsibility. It cannot be an algorithm. It cannot be, I did this because ChatGPT told me to. Is not a viable way to handle this.
Professor, trust in AI often hinges on transparency. Yet, the most powerful models resist straightforward explanation. How do we build public and institutional trust in systems that even their creators can't fully interpret?
Yeah, so I mean, I think the it would require kind of refinement of maybe our understanding of what trust is, right? Even in human institutions, trust is not something that is a binary notion. Individuals sort of grow or learn to trust each other based on the experience that they have over a period of time. And when it comes to people, you make lots of assumptions about that individual that help you kind of interpret the interactions that you have with. So I think with AI systems, if they become complex enough, right, the trust cannot be something that is taken for granted. It has to be earned. And how you earn that trust in the case of AI, how can an AI system earn the trust of people that use them? I think that's an really open kind of largely uncharted research area, right? At what point do you trust it, and in what context, and to what end, right? And if the stakes are low, the trust may come easy. If the stakes are high, the trust may take a while. And it's also a question of it's not always clear that it's just the AI system that is part of this equation, right? Because AI systems are developed by corporations or individuals, and so and they may have their own agendas, right? So it's not always you can't isolate the system from the people that designed it, so I forget who it was that when talking about AI ethics, she proposed this idea that AI systems are like a mirror on human society, right? So essentially, if you talk about unfairness of AI systems, well, that's a reflection of us, because ultimately the systems are trained on the data that from human created data, right? So they're trained on historical data. If society has an issue with fairness, AI system that's trained on that data will have an issue with fairness. So I think it's really this idea of trust. You cannot separate that the system that you're trusting versus everything that has gone into building that system, the data, the algorithms, the goals of the individuals that built the system.
Professor, in your research, you examine real-world deployment challenges. Can you share examples where competent but incomprehensible AI created unforeseen consequences that a more understanding system might have avoided?
Well, I mean, I think there are examples. You probably have seen some high-profile examples of automated driving. That's a scenario where a system that appears competent can make mistakes. The um, I mean, there are even before these modern AI systems, there are examples of AI systems that are trained on data, picking up some regularities that allow it to make predictions reasonably accurately, but you know, would fail in a real-world deployment setting. So, for example, almost a few decades ago, there was an AI system that was designed to tell tanks apart from recognized tanks, okay, in a scene. And I believe what it was picking up was essentially the background, the distinction between the backgrounds. So if you had the same object in a different setting, it would make a mistake, and very highly consequential mistake. I mean, if you're a soldier trying to deal with that, you're relying on this system. So there are many examples of that that one can think of. So the question is, I mean, one could argue that that was because the data set was not sufficiently representative, right? So I mean, algorithms can be made as robust as is, you know, uh, possible given the fundamental limits of learning from data. We understand a fair amount about the theory of learning. So if you give me sufficiently representative training samples that cover all possible scenarios, I could train an algorithm to do accurate predictions without necessarily explaining, right? But it's just making accurate predictions. But many applications, you don't need an explanation if you can guarantee that the predictions are accurate, which is fine, right? So in those scenarios, often the issue is either with the algorithm or with the data that is used to train it. The data sets are biased, and if you don't understand the bias in the data, then you would, this is also a problem with many medical data sets that exist. I mean, the data for a lot of the clinical trials don't have a sufficient representation of all of the ethnicities and the genetic backgrounds and so on, and which causes problems when you use a model that's trained on one population on another where it may not be as accurate.
Professor, some researchers argue we should prioritize inherently interpretable models over high-performing black boxes. Others say post hoc explanations are sufficient. Where do you stand on this debate, and what does the evidence suggest?
So I think it really depends on context, the answer to that question, right? So, and interpretable doesn't necessarily mean, you know, I mean, so interpretability is I mean, just because you can interpret something doesn't necessarily mean that you understand what it's doing. So interpretability also brings an issue with kind of your interpretation of what the model is doing. And particularly with the complex models like large language models, if you ask it, how it came up with a particular thing, it will give you an explanation, which on the surface looks reasonable, but it may be completely made up, right? It may be convincing, but completely made up. So does that satisfy the requirement of an interpretable model? I mean, in a certain sense, it's interpretable, right? Because it gave an explanation of what it did. Is that a sufficient thing? I mean, it's, at least when people have looked at things like mathematical theorem proving, it's possible for a model to get the right answer, without actually having a correct proof, so correct line of reasoning. And so these kinds of things happen. I mean, I would say in general, right, if your goal is understanding, then you're probably better off by starting with a modeling paradigm that is inherently interpretable, at least in the domain. So, for example, if you're doing, biology, you're trying to study gene regulation, you probably want to start with a modeling paradigm that's understood by people that study gene regulation, so that any sort of a model that's created using machine learning is directly testable through experiments. So it doesn't guarantee that the model is right, but at least it's verifiable using the means that we have at our disposal. So that in domains like that, inherently interpretable models that a domain scientist would be familiar with should be preferred, rather than building some complicated neural network that predicts that some gene will expression will increase if some others decrease, but then there is no way to test that because it's this massive complicated black box, right? So it really depends on the context. I would say in scientific kind of domains, understanding is the priority. So it's not enough that the machine learned something. As a scientist, I need to understand what it learned, or I need to learn, right? So that's the goal of science. The scientists need to understand. It's not enough to make prediction. But on the other hand, if it's a low stakes application where, accuracy, like if you're recommending a book to somebody on Amazon, mistakes are not that costly. You don't really need to understand why that recommendation was made, as long as the person likes the book, right? So there are low stakes applications where understandability of the model is less important, whereas some others where it's much more important.
Professor, how do we audit or validate an AI system's decisions when it can't articulate its reasoning? What new governance mechanism or tools are emerging to address this accountability gap?
So audit, again, that has different connotations. So you can I mean, being able to audit means that you have to have a trace of what was done, right? So that you can check. Now, some things are auditable. So the more you document every step that was done with the system, the more transparent the process, and the more open to kind of this side of auditor verification it is. I think how to audit AI systems is an open area of research. I think particularly these larger, more recent capabilities would require even more sophisticated mechanisms to audit. But again, depending on the complexity of the system, not everything may be auditable, right? So there will be trade-offs, right? Just for example, I mean, the giving a justification is not sufficient for audit in a meaningful sense, right? Because the justification could be made up, and at least with large language models, we know that that's possible, as with people, right? So there are the limits to these kinds of things. But if you are, if you have a data set that's going into a training algorithm, a machine learning algorithm, you can check various qualities of this data set. Is it representative of X, Y, or Z? Is it, does it have some bias that we can detect, right? And things of that nature. You can also do sort of perturbation tests. So you can, let's say it's a system that's designed to decide who gets an interview based on their CVs. And if you, uh, you know, change the gender from male to female and keep everything else the same for a population, then would it if there is a difference in outcomes, then that should give you some indication that maybe there is a problem with the way the algorithm works, right? Or maybe there is a bias. It doesn't prove it. I mean, there is lots of other reasons why that might happen, right? So the only way to sort of get at this in a fundamental sense is to run very careful, controlled experiments that test various aspects of the system and understand what's going on. Right, so auditing a complicated AI systems is a non-trivial task. However, one could come up with eventually some standards as to all systems should meet, because the perfection is unachievable. But just like, for example, airplanes, there are standards, right? You would not get on an airplane if it or if airline would not be able to fly an airplane if it did not meet those standards. So similarly, for AI systems that are deployed in high stakes applications, those kinds of standards have to be developed.
Professor, as AI systems become more capable, potentially achieving artificial general intelligence, does the comprehension gap widen or narrow? And will tomorrow's superintelligence systems be even harder to hold accountable, or might emergent capabilities include genuine understanding?
So, I mean, I don't know in precise terms what artificial general intelligence or superintelligence means. Okay, superhuman intelligence means, because intelligence is a multi-dimensional uh, concept. So you take a cockroach and a human being. Cockroach is intelligent in ways human beings would never be. Okay, but human beings are far more capable in many other respects. Right? Cockroaches have survived in this environment, on the earth for much longer than humans have. So intelligence is a very multidimensional notion. And to say that some entity is superhuman, I mean, for example, computers that we have today are superhuman in their ability to do numerical calculations, right? I mean, arithmetic with very large numbers, much faster. So computers are, much more capable of human beings in that respect. So what does it mean to say superhuman intelligence? I mean, what are the capabilities that we are talking about, right? And I don't think that's necessarily clear cut. I mean, I think even, comparing a pigeon versus a human is unclear. I mean, on some respects, yes, but we can't fly. We don't know how to fly, right? unaided flight is not possible. So what is intelligence? And I mean, that's again deeply philosophical. And that's why I stay away from terms like superhuman intelligence, right? On some particular capability, yes, you can talk about that. You know, on dimension X that we can agree on, you can say, well, this machine is far more capable than humans because it can do, accurate calculations far faster than humans. Yes, that's a well-defined notion. But if you say superhuman intelligence, I don't know what that means, frankly, right? And the other thing is artificial general intelligence. Again, it's very hard to say what that means. Is it artificial general intelligence relative to a cockroach? Is it relative to a human? And at what point does it become, general, right? It's unclear.
Professor, before we wrap up, one final question. Looking ahead, what does a responsible AI ecosystem look like? If we accept that some degree of performance responsibility trade-off is inevitable, what quadrilles, institutions, or cultural shifts do we need to manage these systems safely and ethically?
So, at a very basic level, right, there is a deep need for AI literacy at different levels, at all levels of society, right? I mean, as a user of a system, you have to have some mental model of what its capabilities are and what its limitations are when you want to check its results and how. So, when you don't do that, you just blindly rely on what an AI system produces, there can be disastrous consequences. So this is not about engineering AI systems, it's just using them. Right? In terms of, let's say, regulating AI systems or governance of AI systems, at some level, that's a legislative or legal kind of exercise, right? So you set up some guardrails. You say AI systems, this is how you want to deal with it. Well, that means that our people who are going to be in the business of making laws about AI have to understand what AI's capabilities are and what its limitations are at a reasonable level, right? So understand. So that's basic literacy, and this what literacy means will depend on what the person's role is, right? So everyday users needs for AI literacy is very different from somebody that may be using it in a very high stakes scenario, or maybe building more complicated systems using AI modules, etc. Right? So that the AI literacy, and then I think I would say you have to go beyond AI literacy and AI competency. So some level of AI competency would be necessary for pretty much all careers eventually, right? So I think that would help a lot. It won't solve the problem, but it would help a lot, right? So, for example, if everybody that used an AI system uses it critically, right, asks a lot of questions and checks the answers in various ways, the chances, I mean, it won't completely eliminate the chances of disaster, but it would minimize it. So I think that's really so in addition to sort of the governance issues, right, that we talk about, the privacy of data, the ensure that the system is auditable and all of that. I think there's a fundamental, maybe even more important thing is, the people that are going to be impacted by AI or going to be using AI need to understand it at a reasonable level. So that I think is our challenge, going forward. And I don't think the answer is to basically regulate AI out of existence either, because there's tremendous potential for societal benefit with AI, and there's also potential for harm. So the generational challenge is kind of how to you know uh, get the balance in favor of benefits and not in favor of harm.
Professor Vasant Honavar, thank you for illuminating the critical tension between AI performance and accountability. As these systems grew more capable yet remain inscrutable, your work reminds us that competence alone isn't enough. We need comprehension or at least robust governance framework to bridge the gap. The performance responsibility trade-off you have outlined will not only intensify as AI becomes increasingly woven into high-stake decisions, and your insights provide a vital roadmap for navigating the complexity responsibly. To the listeners, thank you for joining us in this enlightening conversation with Professor Vasant Honavar. Until next time, this is Deepak. Thank you so much. Thank you so much, Professor Vasant Honavar, for joining us and sharing your research insight with our audience. Thank you once again.
Thank you for having me.